Question 1. How do ultrasonic level sensors work? Answer. An ultrasonic sound pulse is pulsed 4 times per second from the base of the transducer. The pulse travels through air, reflects against the process medium below and returns to the transducer. The sensor measures the pulse time of flight between sound generation and receipt, and translated this into distance or liquid level height within the vessel. Question 2. What are the advantages of ultrasonic level sensors? Answer. Many application liquids have challenging characteristics that negatively impact contact type sensor performance, maintenance and/or replacement costs. Examples include corrosive, coating, scaling, viscous and dirty liquids. Ultrasonic sensors are non-contact, and therefore impervious to these characteristics. Question 3. What should I avoid with ultrasonic level sensors? Answer. The application variables to avoid with ultrasonic are extreme foam, vapor, turbulence or installation in tall fittings with narrow rises. Foam, vapor and turbulence can absorb and/or deflect away a substantial portion of the return signal. Tall riser fittings can disrupt the acoustic signal path. Appropriate product selection and installation is important. Question 4. What does the 4 to 20 mm signal represent? Answer. The 4 to 20 mm represents the sensor's measurement span. The 4 mm set point is normally placed near the bottom of the empty tank, or the greatest measurement distance from the sensor. The 20 mm set point is normally placed near the top of the full tank, or the shortest measurement distance from the sensor. The sensor will proportionately generate a 4 mm signal when the tank is empty and a 20 mm signal when the tank is full. Question 5. What are the benefits of 4 to 20 mm signals? Answer. Analog 4 to 20 mm signals have the following advantages. The same two wires carry both the sensor power and signal. 4 to 20 mm is easily converted to a 1 to 5 VDC input via a 250 ohm watt resistor or 1 to 10 VDC input via a 500 ohm watt resistor. 4 to 20 mm is low current and therefore has a low heating loss through the signal wire, and with shielded cable. 4 to 20 mm is noise resistant to radiated and inducted interference. Question 6. What is the maximum 4 to 20 mm signal distance? Answer. The sensor can be installed up to 1000 feet from its point of termination using a shielded 18 to 20 gauge twisted pair cable and 24 VDC power supply. The total loop resistance should not exceed 900 ohms. Changes from vendor to vendor. Question 7. Do I have to configure the 4 to 20 mm measurement span? Answer. While the 4 meters A and 20 meters A set point configurations is not fundamentally required, it's recommended because it optimizes the sensor's installed performance. Question 8. Can I reverse the measurement span from 4 to 20 mm to 20 to 4 mm? Answer. Yes, the sensor can be configured such that the 20 meters A set point is empty and the 4 meters A set point is full. Question 9. Can I place a loop-powered level indicator in series with the 4 to 20 mm signal? Answer. Yes, as long as the total loop resistance is less than 900 ohms. Changes from vendor to vendor. Question 10. What are NPT and G mounting threads and where are they used? Answer. National pipe threads are the American standard tapered threads which are applied throughout North America, South America and parts of Asia. G metric ISO threads are the European standard straight threads applied throughout Europe and parts of Asia. Question 11. How do I select the best ultrasonic level sensor range for optimum performance? Answer. Select a sensor range that covers the tank height with at least 25% margin. In challenging applications with light foam, vapor and/or turbulence, select a sensor range that is double the tank height. The additional sensor will improve performance in such conditions. Question 12. What are the ultrasonic level sensor materials of construction? Answer. Electronic enclosures are fire-retardant polycarbonate, cables are polypropylene and transducers are PVDF. The mounting gasket is WITO. Question 13. How do I identify the best mounting location for my ultrasonic level sensor? Answer. The sensor should be located so that the acoustic signal path is free of obstructions from sidewalls, ladders, pipes, mixers and other instruments. The sensor should be mounted level and/or perpendicular to the liquid surface. If substantial foam, vapor and/or turbulence are present, install the sensor in a standpipe. Question 14. What types of installation fittings are recommended for my ultrasonic level sensor? Answer. The sensor can be broadly installed in tank adapters, couplings, flanges, brackets, and standpipes of appropriate size relative to the transducer. Avoid fitting types that substantially recess the transducer into the fitting or compress the transducer against an inner pipe stop. Use plastic fittings whenever possible. Question 15. How tight should my ultrasonic level sensor be installed within the fitting? Answer. In most installations, the sensor is hand-tightened only. If you use a wrench or tool, be careful not to over-tighten the sensor within the fitting.